On the Earth, there are some plates floating on the asthenosphere. When two plates move toward each other suddenly, it will release energy in the form of wave. This will disjoint the building, hurt or kill people, and cause a huge economic losses. And we call this the earthquake. The first research is about the Chile 2010 earthquake. This earthquake had a magnitude of 8.8 on the moment magnitude scale, one of the most powerful earthquakes ever recorded. In the research, the topic is about the disjoint structure in the earthquakes. One of the disjoint buildings is the John Paul II Bridge. After the earthquake, the main cause of failure for the bridge was soil liquefaction due to semi-saturated soils. Soil liquefaction occurs when saturated or partially saturated soil substantially lose strength and stiffness in response to applied stress. Due to high magnitude on the Richter scale, shocks waves from the epicenter lead to soil liquefaction. This caused the foundations of John Paul Bridge to become permanently displaced, causing catastrophic failures in some areas of the bridge. The first project we have did is trying to prevent buildings to fail in the earthquakes. In this way, the column of buildings should be stronger and much stiffer than the beam, and connections between beams and columns have to be very strong. Also, braces are very efficient and important to hold more load, so that it wouldn't be destroyed easily during the earthquake. My teammate and me plan to do 2-story high building, which is made of spaghetti and strong. It is a pity that we have failed to pass through the seismic modeling test, because our connection between each member is not very good, and we do not have enough braces to support the building. The earthquake will also make landslides. So the second project we did is to test the angle change of a sand slope after seismic modeling test. Because we're using the same material, so that the initial slope angle are similar and it is close to the friction angle of sand. Although we didn't make our acceleration bigger than 0.4 successfully, we still find that the higher the acceleration we have, the lower in final inclination of our slope. In conclusion, the challenge 1 point is to let us know more about the Chile 2010 earthquake and learn how can we help the people as a civil engineer, how can we build a more stable building and decrease the economic losses. That's why we are here, try to learn to make the world better.